This is a table that's not in your book, but there's a version of this. Table 13.6 shows you even more, well, different kinds of information than you're seeing here. This is a little more common way to break down the different kinds of fertilizers available based on what's more common and in a general sense. Of course, things can differ specifically to where you are. Some places, like places that raise different kinds of crops, have different kinds of preferences as to which fertilizer they will use. But this is a good table to show you the different kinds of fertilizer that are available. The first one is anhydrous ammonia, and anhydrous ammonia is a gas, and it's a gas that is injected into the soil as a nitrogen source. And so if you'll remember the nitrogen cycle that we've talked about, we put on anhydrous ammonia. Remember that ammonium is the NH4 is actually what is taken up by plants. This form, this ammonia form of nitrogen, NH3, the ammonia form of nitrogen gets converted fairly rapidly to ammonium, and then it can go into that nitrogen cycle and through that process of, if it is going to be going through nitrification, then it'll do that. If not, then it won't. It can be immediately taken up by plants. So a really interesting way to put nitrogen on as a gas. You have to basically knife it in, and then cover up the soil immediately so the gas doesn't escape. It reacts really fast with the soil and actually the soil water, and gets converted into ammonium. So it's a gas, high affinity for water. You do not want to breathe this stuff in. It is absolutely horrible to smell this stuff. It's really incredibly arresting. And in fact, if you're watching this, and this only worked for this semester, but just recently in the town of West in Texas, there was a giant explosion at a anhydrous ammonia production facility, and so this material not only is pungent in terms of if you saw it, it's a white gas, in terms of if you smelled it or saw it, but also it is highly explosive. Killed several people, flattened houses, 2.1 on the Richter scale. We're talking really big reactivity of this material. But this is the main way in American agriculture that we put on nitrogen. Urea, probably the second most popular form of nitrogen. It's so high form of nitrogen. See this 8200? That means we have 82% of that material is nitrogen. Okay, urea is a granule, so it's a little prill, or a little. If you're familiar with the candy nerds, let me get a picture of that real quick. So I went and found some pictures of this. This is what anhydrous ammonia application looks like. So you have these tanks of anhydrous ammonia gas, and running from these tanks are tubes. These tubes will go to each, in this case, each coulter, and each knife or each injector unit will inject. See that little tube running back there? They'll inject that gas into the soil, and it'll immediately react with the soil water and become ammonium. Okay, so there's that. And then urea, we talk about prills. This is a prill, so each one of these little granules here is called a prill, and this is the way we apply. Urea is as a granular form. We spread it over the ground. Typically, you want to till it into the ground so you don't lose this later on as ammonia gas, because you can have loss of this material as a gaseous form if you're not careful. That's one of the things you have to worry about urea. We have some other forms. So this is a coated urea form, a little bit lower. So that's 46% nitrogen. This is 44 because we have to account for the coating. And this helps keep nitrogen from being lost due to conversion to either to loss via leaching or loss from ammonia gas leaving leaving the soil. The next one is a UAN, which is a solution. That's a liquid solution that's 28% nitrogen that can be sprayed on the ground itself until then, or it can be sprayed onto the plants. And there's some plant uptake of this material. I'll put these pictures in the course so you can look at them a little bit further and look at some of these comments. But the same sorts of things are in table 13.6. Okay, ammonium nitrate. This is less used than it was. If you've heard of the Oklahoma City bombings, this was material that was used in that. So this has kind of faded away to some extent out of being used because of that particular incident. But it's another form, 34% nitrogen. We're moving now to our phosphorus fertilizers, and what you'll see, interestingly enough, phosphorus is this middle number here. So when you see the first number is nitrogen, the second number is phosphorus, the third number is potassium. You'll be learning this on page 479, box 13.6. Tells you about the concentration amounts. But usually you see these three numbers, and the first is nitrogen, second is phosphorus, the third one is potassium percentage in that material. So if you had a 100-pound bag of ammonium nitrate, you would have 34% or 34 pounds of that as nitrogen that's available to plants, or total nitrogen. So in this case, for most of these phosphorus sources, these up here, you have the bigger number obviously is in the middle. That's the phosphorus number there. So 52% phosphorus for this monoammonium phosphate. We also have diammonium phosphate, and you'll remember that ammonium is a form of nitrogen, right? There's ammonia and ammonium here, and so we find that with these you have when you apply some of this material, let's say we apply this 1152O. When you apply some of that material, when you apply 100 pounds of that material, you have 52 pounds of phosphorus, or what we call available soluble P2O5, or sorry, available P2O5, and you have 11 pounds of nitrogen applied. So when we break this out, we say, this is a phosphorus source here. Well, it is a phosphorus source, but it's also a source of nitrogen. We can put that on, and we get some nitrogen along with it. Same thing for diammonium phosphate, a very common phosphorus fertilizer, is 18% nitrogen, 46% phosphorus, and 0% potassium. Okay. We have some other triple superphosphate. This is kind of a well-known version of phosphorus. But now it's just a game of sort of what your local co-op is providing, and they might provide anhydrous ammonia services. They might provide a mix that's common in the area. It depends on what area you're in. And what they might do is they might take a couple of these. They might take urea, and they might take some triple superphosphate and make a mixture that is suitable for their area, for whatever they're growing. And so you might have a mixture that is available at a co-op that's different from all of these. It's not just one of these. Maybe they mix a couple of these up and provide a particular mix of fertilizer to go on fields in that area. But this is the substance that they make that material out of. This is these are the potassium. The main potassium source here, 0060 potassium chloride. That's a common source. That 0060 up there. So 60% of that material is what we call water soluble K2O, or just, you can think about it as potassium. We have some other forms. So we have some sulfate that can be a commonly applied nutrient, and we add this number here at this fourth number here to indicate the amount of sulfur that's put in when you use those kinds of fertilizers. Here's an example. So you see this combination of blended fertilizers. So we can blend fertilizers up, and we can get different kinds of. So we can get a 27-27-0. So mostly, or 27% nitrogen, 27% phosphorus that's applied to a field. Some with micronutrients and all sorts of other things. But these are the common types of fertilizers that are available for purchase, both for homes sometimes and in those kinds of applications, and for major agricultural crops. This is how we get, typically in our day, this is how we get fertilizers that we need in high amounts onto the fields in a ready format for plants to use. That's one of the keys to all this inorganic fertilizer, is that when we put them on, they typically are very ready, very available to plants when we first put them on. That's kind of a key of why we would do this.